For this fourth tutorial, we're going to look at the VOP node, or to be more precise, the attribute VOP node. And I'm going to show you how you can use it to create a low polygon little planet with natural surfaces and variation in tree growth very simply. This is a fairly advanced node, so I'm not going to cover everything. That would take me hours. So we're going to look at the basics. It's quite early to get into this, but I think it's so powerful and so useful that it's worth introducing you to it early on, and you're going to be able to do a lot with it. So let's start by dropping down the geometry node. Now we're going to put in a sphere because we need something to work with here. So we'll drop in a sphere and let's make it a polygon. That way we've got a nice even distribution of points over the surface, and we'll increase the frequency. Let's make it 10. Now we hit tab and type AV for attribute VOP. The attribute VOP is a vector operator, and what it allows you to do is take the components on your object and edit all those components at the same time. It's actually a variation on a shader network, so if you worked with shaders before, you'll probably find a lot of things in common. In fact, it uses the same network as Houdini does for its shaders, so we'll be covering that again later on. If we open it up, you'll see what we have in here is another network. Only instead of running from top to bottom, we're running from left to right. We have a menu on the left which represents different attributes which we might want to manipulate. And on the right we have the outputs. If we look at the attribute VOP top level, you'll see that it's running over points. You can change this, so you could ask your attribute VOP to run instead over primitives or vertices, and there's actually a variant on the attribute VOP which you can use for manipulating volumes. For now though, we're going to look at points, and the principles of the different types of attribute VOPs are the same. So let's open it up and look at the various attributes and compare these to the geometry spreadsheet. You'll find this alongside your scene view. I refer to this so often that I usually make a window for it so that I can keep it open. So let's split the pane top bottom, and you'll see you have a copy of the geometry spreadsheet here. You can pull it down because we only need to see the first few points, and then go back to our scene view. Now, the geometry spreadsheet shows you the attributes on all the different components of your geometry. The first one is points, which is what we're working on now, but there are also values for vertices, primitives, and detail, which is a special kind of attribute that's attached to the entire object, so you only have one detail attribute per object. Now if we go back to points, let's connect up the sphere because we don't have anything in there at the moment. Now you can see that the Px, Py and Pz have values, and there's a value for every point. These represent the positions of the points, which is pretty straightforward. So if we were to move the sphere, these would change. So let's scale it and see the point values changing. At the moment, these are the only attributes that we have. I'm assuming that most of you will have worked with shaders before, but in case you haven't, I'm going to give you a quick tutorial on using maths to manipulate values. If you hit the tab menu inside the VOP node, you'll see you have a completely new menu of nodes, which can be a bit overwhelming. However, a lot of them are very specific, or they're not relevant to geometry, so a lot of these nodes are designed for shading. So there's actually a fairly limited number that you will use 90 to 95% of the time. So we're going to look at these. First of all, I'm going to drop down a constant node. Constant is simply a set value, so it defaults to 0, which we can plug into one of the attribute outputs. And I'm going to plug it into CD, which is the Houdini symbol to represent colour. So it has 3 channels, R, G and B, and you can see them here. And because I plugged in a single value, it set that value in all 3 channels. So we have 0, 0, 0. Now if we change that value, it will increase it. So if we bring it up to 1, 1, 1, we now have white. However, a colour you would expect to have 3 individual values. So let's turn it into a vector. A vector is basically a number that's split into 3. So you're looking at 3 different fields. And this is exactly what we want for colour. So now if we make the red a value 1 and keep the green and blue at 0, you'll see we get a red sphere. And we can start mixing these. So let's make the blue one as well and we get magenta. This isn't a terribly intuitive way to input it, so we actually have an option to input the colour directly. Now when you're working with shaders or with VOPs, you can start manipulating these colours. So let's try multiplying 2 colours together. I'm going to put down another constant. This time I'll just type in constant, quicker. And change that to a colour. And now put down a multiply node. Multiply node will just keep adding input, so you can keep multiplying as many values as you want together. So now we'll put the output into colour, and you'll see we once again have black, because if you multiply anything by 0, the result is 0. If we start increasing these values, you'll see we're approaching our original colour again. So for the result of the multiply node, you will get each of these individual values, so multiplied by each other. So 2 by 0.18, 1.6 by 0.075, and 2.1 by 0.616. We also can add these numbers together. If you add 2 values together, you will always get something brighter, unless one of them is negative, of course. So we're now looking at a brighter value than the original one. When you multiply 2 numbers again, provided you're multiplying by something less than 1, you're usually going to come out with something darker. So now let's look at some of the types of nodes that you might use day to day in your VOPs. First of all, we have the combine nodes. These include your adding, your multiplying. So this is how you would blend together 2 different values or more than 2 values. With some more complicated ones here, like maximum will always look for the largest of the 2 numbers that's coming in. Color mix is quite a nice one, so we can put our 2 colors into the first and second inputs and then play around with the bias, which will blend between the first input and the second input. The next useful set of nodes are the convert nodes. Most of the time you'll be looking at float to vector or vector to float, and this will allow you to convert through from a single component value such as 0 to a vector such as 0, 0, 0, which is the sort of thing you would need for color or position. Next we have the math nodes, which we've touched on already. Anything that you can do with two numbers you can do in VOP, and you can achieve some really interesting effects with these. For example, if you take the sign of a value, you can start getting values that move between 1 and -1 instead of a straight linear value. But again, this is something that we'll be looking at in future. Then we have noise, which is a lot of fun, and we're going to look at that in more detail in a minute. And patterns, which again we'll look at in a minute. And finally we have the utility menu, which contains bind and bind export, which allows you to create your own attributes to attach to your points. And we'll be looking at that later. Now I'm going to delete what we've done so far and look at some of the things you can do with the position node. So at the moment, the position that we have coming into this node is the same as the position that's going out of the node, which is the same as a straight line from P to P. But we can start to do some things with it. Now let's try adding. Let's type add. There's a variation on the add node called add constant, which allows you to just input a value for the second number. So you can see here that it's added 1 to all the P values. You can see them changing down on the left. And what we're doing is moving the entire object by 1 in all directions. What's usually a lot more useful when you're working with position is to work in the direction of the normal, and there's a node to do this. So if we type in normal, we get a node called Displace along normal. And let's hook this in. And instead of adding R1, we want to have a constant value. Oops. And we put this into amount. So now each number that we add is being added in the direction of the normal. If we turn the normals on, you can see this. So we're going a little bit further along that normal line now, every time we add some more to it. We don't have to keep our attributes separate either. We can start mixing them up. So for example, if we take our position attribute and plug it into our color, we now have the position value represented by red, green and blue, which can be really useful to see what's going on. It takes a while to get your head around the idea of seeing position in color. You can see the bottom left corner is black because all those values are less than 1. It's one of the limitations of displaying numbers in the color is that all values under 0 are displayed as black. Now we're going to take a look at the noise nodes. So let's type in noise, and you'll see there's quite a big collection of them. The simplest one to work with is the anti-alias noise, which gives us a nice soft cloud. It requires, as a bare minimum, a position input, which tells it whereabouts in 3D space the points are sitting. So if we hook that up to our position and then put our noise output into color, you'll see that we're getting a cloudy output. An awful lot of it is black, and that's because, as I said, everything underneath 0 is represented as black. And the output of noise is actually, well, we can see it here. So if we look at the colors, we click this, we'll see the maximum value is 0.3, and click it again and the minimum value is 0.31. The easiest way to fix this is to use a node called fit range. Type in fit, that's the top one that comes up. So we'll plug that in and you'll see we've got 4 values here. This is the values going in and out, and this is the values, sorry, this is the maximum minimum going in, and these are the maximum minimum coming out. Now we want to take our values going, if we looked on here, I've lost it now, let's plug this back in. So our lowest value is minus 0.31, so that's our source. And our highest value is 0.38 approximately. And we want to take that range and squeeze it into 0 and 1 so that everything is visible in our colour. So now you'll see there are almost no completely black points. It can look like the noise we're seeing is wrapped around the surface of the sphere, but in fact what we're seeing is a sphere shape cut into a 3D volume of noise. This is a bit clearer if we start playing around with the noise, so we can offset it. Now you can see it's moving. Now if you imagine the sphere as a sphere of light inside a smoky room, it might be a bit easier to imagine what you're seeing. So the smoke is moving across the sphere and it's just picking up the intersections. We can change the frequency and we can change the strength, and we can work on the roughness, which is, it's like a second level of noise on top of the first very simple one, which gives you a bit more detail. You're not getting much resolution in this because there isn't a lot of detail in the sphere, so there aren't actually that many points to work on. If we go back to our sphere and increase the frequency to 20, you can see a bit more detail. Let's ramp it right up to 100 to see how it looks. So now you can see that there's a lot of detail in the noise. The only reason it looked blurry to us is because the sphere was quite low resolution. This is going to be slow, so I'm going to take the frequency back down to 20. The output we're looking at here is 1D, which means it's a single component, and the result is black and white, but we can change this to 3D noise, so each colour channel is being acted on individually. And now that we've got 3 colour channels, we can also add this to our position. So let's plug it into the amount of our displacement along the normal. So now you see that all the points are being offset by different amounts. This is probably a bit much, so what we want is a way of toning it down a bit. A nice node to use for this is the mix node. The mix will let you have 2 inputs and it will allow you to scroll between them, so you can use more or less of either one. So for this one we actually only need the input of our noise, because our second input we want to be 0, so no influence at all. And plug that into amount. So the bias is taking us from the first bit input, which is 0, so you'll see that's back the way it was, and the second input, which is no influence at all. So this way we can pick exactly the amount of displacement that we want. Let's go back to 1D noise now, because it makes things a bit simpler to understand. So you can see the areas that are white have been offset by more than the areas which are black. Now let's look at some of the other types of noise. There's a variety of noises here, but actually the easiest way to access them is using the Unified Noise node, which actually contains all the different types within one. So let's plug our position in here. Got a lot more options here because there's a lot more to cover. And output our noise. There are a huge number of settings here, so take a look at a few of the different noises. And probably the easiest way to show you this is to look at the Unified Noise help documents, which has illustrations of lots of different settings that give you interesting results. So if we open this up and scroll down. So you can see there's some really interesting stuff that you can do with these noises. Each of these has the settings that we use to achieve it. You can create more complicated noises by taking the output and performing maths on it, or combining two different noises as well. I think at some point in the future we'll have a tutorial just devoted to noise. So I'll delete that for now. Another set of options that's quite interesting are the patterns. So you'll see here there's some more artificial shapes. Let's, for example, look at the stars. Something that distinguishes patterns from noise is the patterns work on UVs rather than positions. What we can do is take the P value and plug it into UV, and what this will do is take the first two components of P, so its X position and Y position, and use it as UVs. So let's have a look at how that would display. So you can see effectively it's as if we're projecting it in the Z axis, and it's only using the X and the Y. I'm going to jump ahead a little bit and put some UVs in here. And by default, UVs work on vertices. That's nearly always how you'd want them to work. But because we're working with points here, we need them on points. So we'll plug it into our points. And let's go back into our attribute VOP and plug our UVs in. And now if we make changes to our projections here, you'll see that it affects the way the image is displayed. Right, let's go back in and play around with our stars. If we increase the frequency, we'll make a few more. Make them a bit smaller, make them a bit random. And in the same way as we use the noise, we can plug this into our displacement as well. So we get some interesting effects. Now we're going to go back to our noise and use it to actually create something. So we'll delete the stars. Plug the output of our noise into colour and into our position. Let's increase the frequency a bit until 2. And we've got something that might look a little bit like a planet. To get our colours, rather than using the 3-dimensional noise, which is a bit hard to work with, we're going to use a colour mix node, which we looked at briefly earlier. Instead of plugging in our primary and secondary colours this time, we're just going to use the ones that are inside the node. So if we plug let's take our fitted noise and put it in the bias, that's what blends between these two colours, and then stick this in the colour output. See, now we're getting 2 colours. And we want the low areas, which are currently pink, to be blue, because this is going to be our sea. And we want purple areas to be a kind of sandy green. This is going to be our land. There isn't a lot distinguishing the two colours at the moment, so if we play around with our fit values, we should be able to change that. So let's try bringing these values a bit closer together. Let's make this 1.2. Yeah, so you'll see that by bringing in the inputs to closer to a single number, we're establishing a threshold. We don't want it to be a completely sharp line, but we want it to be a lot closer than it is at the moment. Let's try 1.1. So this is starting to look a little bit more like sea and land. Noise is probably a bit random at the moment, so if we take the roughness down a little bit and go back to our values here again. There we go, that's a bit better. Now we want to make our land higher than the sea and give that a nice sharp offset as well. So we'll take the out value from here and plug it in. So we don't want to offset it by quite as much as that. There we go. And I'm going to make our sphere a little bit lower resolution. Let's try 16. And finally we want our edges to be hard. So we're looking at intentionally low polygon object. So here at the moment we're displaying our edges as smooth. We'll change them to flat shaded, and we'll keep flat wire shaded so that you can see the edges on them. Let's play around with our settings a bit more. Here we go. So now we've got a little planet with some islands on it. Back to the noise and tweak the frequency a little bit. Make our islands a bit bigger. Now we want to try growing something on our land. To do this, we're going to create an entirely new attribute from scratch. So if you look at our spreadsheet now, we have 3 different attributes. We have position, colour, and our UVs, which we plugged in earlier. Now we want another attribute, which is called pscale. This is a very special attribute that you can create and manipulate within Houdini, which can be read by different types of nodes. And it's basically scale per point. The points don't have a scale, so you wouldn't see that normally. But if we're using those points for something else, it can be really useful to have a scale attached to them. So I'll demonstrate. First of all, we want a bind node. The bind node will either bring in attributes from outside, or will allow you to export new attributes from the VOP. The one we want is bind export, because we're creating a new attribute. And at the moment, let's just try plugging in again our fitted noise. So the pscale is a one-dimensional value. So it's simply a single value. And we have to call this value pscale, all lowercase. And that way Houdini knows what it is. I know this doesn't sound like a very procedural way to work, to have to know the names of values that do things, but in fact this isn't. This is fairly unusual within Houdini. Most of the time we'll be creating our own names for attributes and then reassigning them elsewhere. So it's a simple float, so we can leave that as it is. The default 0, which is what we want. And we don't need to hook this up to anything because this effectively is an output node. If you look in the geometry spreadsheet now, you'll see we now have an attribute called pscale. Now let's give it something to do. I'm going to give you a quick preview of a node that we'll be looking at soon, which is the copy node. Copy to points. And what this does is takes an object, which we put into the first input, and a group of points in the second input, and it copies one instance of each object onto those points. So in the second input we put our sphere, and we use the points from that sphere, which, switch them on to remind you, look like that. Now each of those points now has a value called pscale. The second input, I'm going to put one of the trees from my fairy ring in the first tutorial. So I'll drop down a file node and load up one of my trees. I've saved it as a geo, which keeps the colour information, which is quite nice to have. And then we plug that in. Turn the points off. So what we're looking at here is lots of copies of trees placed on each of the points and scaled by the pscale value. So Houdini will look, when it uses the copy to points node, it will look to see if that pscale value exists, and if it does, it uses it for scale. So now each point has its own scale attached to it. These trees are actually rotated incorrectly. Let me just fix that. There we go. So now all the trees are sitting on the surface of the sphere. We're only seeing the trees because the copy to points isn't taking the original input, original object as an input, it's just using its points. So now we need to merge it with the original sphere again, so we can see the whole lot together. There we go. Now this is probably overkill on our trees, so we want to reduce those values a bit and maybe add some randomness to the trees. Something else that is happening that we don't really want is the trees are being tinted by the colour of the object underneath. So you can see each tree is just a flat colour that it takes from the point. If we go into copy to points, we'll see there's a list of all the values that are being copied from the points, and we can add or subtract from these. The little hat symbol will remove a value, so if we type in the hat and then CD for colour, so you can see that's the same as the attributes colour values, hit enter. Now it's removed the colour value and it's using the original colour of the tree. Let's go back into our VOP node and see if we can thin out the trees a bit. I'm going to do this by adding another noise that's offset slightly. So I'll copy and paste that. And to combine them, I'm going to use a maths node called min, which which takes the lowest of the two values, and this will ensure that our tree values are never higher than the input, which means that where there's water, the water will keep those values below 0 and we won't get any trees growing there. This is only for pscale, so let's take that as the output of fit and plug it into our bind node. And now our trees are much smaller, still pretty even though, so we'll turn up the frequency, see if we can get a bit of variation into this. There we go. If you want to know what's going on, it can be helpful just to temporarily plug this into the color node. Now you can see what it is that's actually driving those values. Turn the frequency up a bit more. So you can see there's a lot more randomness going on there. Put our original color back in. And let's turn everything up a bit. We're getting some odd patches here, and in fact what you're seeing is because these values are less than 0, you're having negative trees growing inside your planet, which isn't really what we want. So we want to clamp everything to make sure that nothing is ever less than 0. So we'll use another maths node called clamp. And now our lowest value we ever get is 0, and you can see that the inside out trees have gone. So now you can see how you can use a VOP node to create a huge number of different effects and something quite organic from our noise. There's something else I want to cover quickly. You can promote parameters so that they're visible on the top node if it's something that you might want to change often. So say for example our amplitude of our tree noise, which controls the overall height of the trees. We might want that to be available to somebody who doesn't know much about VOPs. So we want to be able to promote that parameter. We want to be able to access that quickly. So what we would do is middle mouse click on our amplitude node and go to promote parameter. And we get this little nodule here, which you can actually click on and give it a name. It's currently called amplitude, which isn't bad, but let's change it to tree growth. And we'll give it a range. Currently the range is -1 to 1, which isn't very useful. Let's make it 0 to 10. Now, if we go up to the top node, you'll see that there's a parameter called tree growth with a slider. So now we can interactively change the size of the trees on our little planet. One last thing I wanted to show you is the VEX code that's being generated by your VOP. So a vector operator is actually simply an interface for creating VEX code on the fly, and you can have a look at that code. So if you go to the symbol on the top left of the parameters view, and go to Vex VOP Options, View Vex Code, you'll see that everything that you've just written is contained in this bit of code, which is actually very simple considering the amount of nodes that you had to set up. And if you're someone who's more comfortable writing the code, then you could do this by hand. And in fact, there are some situations where it's easier to write the code than it is to try and do it within a VOP node. For example, if you're using loops, it works much more easily in Vex. But we will go into that later. It's not something that you need to worry about now. Now that you have your completed planet, you might like to try plugging in some different shapes. Because Houdini is procedural, anything that you have applied to your sphere can be applied to any object. So let's try changing it to a grid. Our grid's far too low res, so let's up that a bit and make it 100 rows, 100 columns, which requires a little bit of thought. There we go. So now we have our trees growing on the surface of a grid, or we could have a sphere. Sorry, a box. Add some divisions. Box is pretty distorted because we're pushing the position of the vertices out. Let's add some more divisions. It's quite interesting. So in a game situation, you might imagine that you package up this little group of nodes here into a tool or a Houdini digital asset and allow the user in Unreal or Maya, wherever objects are being created, to put in their own surface. So we have here a planet and tree generator. I hope you've enjoyed today's tutorial. If you're unfamiliar with using maths to manipulate colours and positions and attributes, then I would recommend that you spend a good bit of time trying out different nodes and seeing what kind of effects you can get and playing around with noises. And as I mentioned, also taking a look at some of the examples in the unified noise documentation. I'll put a link to that below. Please subscribe to my channel and see you next time.